Hello everybody, welcome to another blog workshop. My name is Nikita Fuchs from the wonderful Blog Factory. And today we're going to put the heavy machinery aside because after last time we used some really heavy tools to see how you build an awesome contract on the Eternity blockchain. This time we're going to go one level higher in the stack and go soft. Yes, we will check out how the software development kit, the JavaScript SDK of Eternity works, how you're going to set it up, how you use it for deploying smart contracts, how to interact with them, and some other nitty-gritty nice stuff. Just check it out. Let's jump right in.
Let's go ahead and install the latest version of the SDK. At the time of the recording, this will be version 8. Before we begin to write our code, let's first get ourselves an Eternity account key pair with some free AE to use on the testnet. The easiest way to quickly obtain a key pair is to use the Aeternity CLI. That's how you get it. Never use any public tools from the web for generating keys for critical things like storing mainnet AE or interacting with important contracts. Never. After installation, run a CLI account, generate 2, and hit Y to have 2 key pairs generated. Now you can head over to Eternity's testnet faucet and have 5 testnet AE delivered to your accounts. Just give the blocks a few seconds to be mined. Now let's get started and check out this example to see how Eternity's SDK is set up. You can find a Git repository with the full example code in the comments. Just use your own keys, ideally, of course.
And just for a quick note in between, during the recording of this video, Eternity was undergoing its Iris hard fork protocol upgrade. The mainnet is not updated yet, while the testnet is. So for the upgraded networks, please use the SDK version 8. And for the not upgraded, still use version 7, please. Look it up on the internet in the documentation. They have a slightly different import path, but if summer 2021 already went by, I think this should not be relevant anymore to you.
The SDK supports flavors, allowing you to reduce your bundle size, but for simplicity, we go for the universal flavor today. Next, we define the variables to hold our public and private keys. We use them to instantiate so-called memory accounts inside our applications. These accounts, as you might have guessed already, live only in memory and will be used for blockchain operations. After the SDK is set up, you can add more accounts on the fly later. Check the docs for according commands.
And as you see with the hard-coded private keys, this method is suitable only in your backend application, right? So repeat after me. I will never hard-code private keys in my web app. You understood? Yeah, we're gonna do another video to show you guys how to implement Eternity Superhero browser add-on web wallet. But stay tuned for a separate video on this topic.
Now let's get to it. Define an async function so we can use JavaScript's await syntax. Of course, we need at least one node your SDK can use to speak to the Eternity blockchain. This can be your private node or any node running on a network your accounts have funds in. In the argument object of the SDK setup, you can provide an array of nodes to use, but we'll stick with one. URL is supposed to point to a node for sending transactions, and internal URL for executing local smart contract code, which theoretically not all public nodes could allow. For the time being, you need to provide a URL to a hosted compiler, which can either be the public one Eternity is running, or your own one you can run locally on your machine easily in a Docker container. Very soon, a JavaScript-based compiler will be available in the SDK, so this step could be omitted. In accounts, we put the memory accounts we just previously defined, and address takes the public key of the accounts you want to use for any operations by default. And finally, to test our connection to the node, let's ask for the current block height. Let's save it and give it a run.
Boom! And that was even the hardest part. You don't believe me? Okay, well, we got the SDK set up. Why not just try to go and deploy a smart contract? But don't get ready to go and fill up your coffee cups, guys, because thanks to Eternity's fast microblock times, this will not be a long wait.
Head over to your favorite Sophia IDE and copy your contract code. You can use any example code you want to, of course. Create a template literal and paste the contract into it. Watch out though, IDEs tend to sneakily tamper with the code's indentations from time to time. To test whether your IDE is doing that too, you can hit undo once after pasting and see whether your formatting was changed or not. Overall, just make sure it looks the same as an AE Studio. Next, we create a contract instance with the help of our SDK. By acting like we're executing our smart contracts init function, we actually send a transaction to deploy the corresponding smart contract to the Aeternity blockchain and thereby, implicitly, have its init function run with the parameters we pass. It's worth to log the contract instance and see what useful information it has to offer about the contract you just deployed. Its newly created address and information about the transaction can be retrieved like this. Let's save it and give it a run.
Alright, I see it, you're hot. So we've got the SDK set up, we've got the contract deployed, good job. Take a refreshment. And now let's walk the last mile and actually call a function in a newly deployed smart contract. But don't be disappointed, it's actually easier than you might think.
Go ahead and create a try-catch clause. Calling your smart contracts functions goes as easy as this. You can also make yourself a small helper like that if you want to. For every function you define in your contract, you have a member function inside your contract instance's methods member. One cool thing is that the SDK just knows which function just reads data from your smart contract and which actually changes the state and therefore requires a transaction to be done. If you want to play it safe, you can explicitly state the behavior of every function call. Here's one cool thing though. You can dry run stateful functions for testing and curiosity. Thereby you will find out whether they would be executed properly at that very moment, meaning block height. Back to calling your function. Just pass your parameters neatly formatted like shown in the previous video. Again, just like with contract deployment, it's worth taking a look into the call result. If you want to choose which of the previously added accounts you would like to make this call from, pass an option object to your call like this. There you can also define the amount of ethos, the smallest fraction of AE, to be sent along with your transaction. The same is possible for contract deployments too. Check the SDK documentation for more cool tricks you can do in the options. One last easy and useful thing for you to know. Simple transfers across Eternity addresses are done like so.
Woohoo, champ! You made it! So today you learned how to generate an Eternity key pair and get some free testnet funds, how to set up the SDK, how to deploy a contract, how to call its functions, and how to do a value transfer across Eternity wallets. Awesome. So now time to go and build something cool. The Lambo won't earn itself. So if you would like to see more technical content on Eternity, hit like, subscribe, ring the bell, feed your cat, clean up your room, and so on, the usual YouTube stuff. If you got any questions, we'd love to hear them in the forum. And yeah, you'll find the repository with the working code from this video down in the comments and so on. Happy building!